Hello and welcome back. Today I'm going to build an RF sampler or an RF top, which you use for high power. If you want to measure, for instance, on the spectrum analyzer, you cannot just connect your transmitter directly because yeah, it's too much power. So you will burn you really burn your sensitive equipment. So don't do that. So and then you yeah, what you do, you build some sort of attenuator but as an RF top. So let me show you the schematic, and also I will zoom in on the spectrum analyzer why you need that. So here we have the Marconi. This one is built to handle RF power. So if we zoom in, you can see this one can do 75 watts. So that is a lot. That is yeah, that's almost like 50 dBs. So that is a lot. But if we have a look at the spectrum analyzer right here, and I zoom in, you can see this one can only it can do 20 dBms. And if you talk about watts, that is around 100 milliwatts. So if I have my CB with 2 watts or 4 watts, or I have a proper 2-meter transmitter with 50 watts, you can imagine this is not going to work. And I notice now also you need to also be careful always with spectrum analyzers. Some cannot handle DC. You will immediately blow them. But for this one, it's no problem. So I do not need the DC blocker. But that you could also build into your RF top if you are afraid that you're gonna blow your sensitive devices because of DC. The same here with the little USB spectrum analyzer. I hope you can see with the light. Let me zoom in. Here it says RF in below 10 dBm. So this one can only do 10 milliwatts. You can imagine you will blow it with your transmitter. So I've been looking on the internet and I found different designs. And well, it's actually constantly the same one, and it's for the 40 dB. What you find most of the time that this is just a straight. So this is your transmitter. Here you put your dummy load or your antenna, and then you just step right from it, just on the connection. And if you want 40 dB, you do 820, 820, 820, and here you put your 50 ohms. And yeah, here they try to make some sort of capacitor. I think this is for the lower frequency in the high powers. It's just a piece of wire. And if you look at it in a simple way, then this is the same. This is also 820, 820, 820. This is just a straight. And well, it can be even simpler if you just put here 50 ohms. So you see, this design is exactly the same. So I also don't remember which website it came from, otherwise I would have told you. But the design is the same everywhere. Here also it's the same. Here they even say 100 watts. And here they put 1.65K. So this is, instead of 820, it's 825, 825, 825, 100, 100. This is also 50. Again, same design. Here they also worry about the DC block, so they put just a little capacitor here. Just to block the DC if you have a spectrum analyzer that cannot do that. Here they mention already that it can do 100 watts because most of the spectrum analyzers already have an own attenuation of 10 dB. So then including the 50 here, then we have a 50 total, and then you can do 100 watts. So, and if you build that, yeah, you can do it also with a little circuit board, but some also just do a piece of electricity wire here. and you solve directly the resistors on that. And you can build that in this little, I think they call it a Hammond box. And well, if you put there your, you can do it all with BNCs, BNC, BNC, and one for your tap here. And yeah, so that's easy to do. But I also found another design, and that one I do remember because I think it was from the TRX bench. Peter is back, I saw, and he built something like this, and that is a variable one. And again, you're in and you're out. It's just a straight one. Then your tap, this one is not directly connected, but with a little coil that you can make yourself. I do have the stuff with this. You put 12 turns of wire in there, and the wire goes through it like this. And then you just need a 50 ohm resistor here, a 22K pot, and a 22 ohms resistor. You put those in parallel. Well, I like both the designs, and I'm gonna build them both. And instead of building it in this little box, I'm gonna build it in a bigger box. And then I can do them both, because one is directly connected. That was the first design with resistors. And instead of doing 1 watt resistors, I will use 2 watts. So it can really dissipate a lot of power. I did find already the big wire pots. These are 47 ohms, I think, instead of 22. So I just put a big resistor in parallel. The design says to put 22 also in parallel. So I can do that also parallel on this one. It doesn't matter too much, it's just a little bit different. I have wires also. And so I have most of it. I have my BNC. But I also gonna change the design a little bit, because in both the designs it is really made as a tap, and it expects to have some sort of load. So you need to, if you build this, you put your RF in, you have your RF out. So if you want to use it, you need to put a dummy load external or an antenna. And that is also nice, but you don't always have that. So I was thinking, I have this dummy load resistors. This dummy load resistor is also for 100 watts. So I was thinking to put on the output a switch that I can switch to the dummy load resistor and the BNC out. And then I make it switchable. And that works immediately for both the taps that I'm going to make. So and that's why it's also nice to have the big box, because you need to dissipate a lot of heat. So if I put the resistor somewhere in the middle, put some paste, then the whole box can dissipate that heat. So, and it's easier to work with the bigger box. And so then we have a fixed output of 40 dB. We have a variable one also. And maybe even I'm going to make a frequency counter output that is even a lower level. And I can just use the RF tap as well. But if I want to use them both at the same time, I will just drill a hole, put the BNC, and it will probably, because the signal is all in the box, it will probably just pick it up. And if it doesn't, I just put a little centimeter of wire there, and then it will pick it up anyway. So then I can do everything at once. It is a dummy load, it is an RF sampler, variable, fixed, and I can have an output for my frequency counter. So let's start. What is this? I also have an IC tester. I show you next week. So the plan is, because I'm gonna do both options, drill a hole here for the input, drill a hole here for the output, make also a little hole here for the switch, and then the resistor in the bottom there. And if I make the first one the fixed stop, I will build that here, this way. And the variable one is gonna go here, like this. So first I'm gonna just drill the holes and then you will start to see. Okay, well, let me just start by marking the holes. We'll do 2.5 centimeter from the side. No, from here. 2.5 from here. So I did drill the holes. I didn't have a drill that was big enough, so I used this special drill. But it does fit now. So this can be this side. This goes here. And the switch goes here. We forget this one for a while, and we just have to switch. So if we do like this, we put just straight through, goes from here to here, and then with the switch, we can, if we do the switch up, we have the upper pin, and it goes directly to here. And if I switch it to the lower pin, it will just go here, and we put the resistor here on the bottom. So I will now mount the resistor here, so we can just solder the pin like this. Now we can still reach it. So I'm thinking to put a resistor right here. It doesn't need to be exactly in the middle, but I don't want to put it too close. So I think if I put it like this, the wire in between is not going to be too long. And it's still sort of in the middle, so we have the best dissipation there. I will move it a little bit like this. And then we put the paste. Okay, now we have everything connected. Well, not connected, but all the holes are there. So what was it again? Let me just put it down. So here we have it. We have our input. Here we're going to have the straight through to the switch, switches to the output or switches to the dummy resistor. Then we're gonna tap here the resistors and then go to this output. And this is then the fixed 40 dB. Here we're gonna have the variable, and that is going to be with a little coil that we need to wind, and that is going to be just here. And then the variable, and then out here. Here you have an extra output. I will just do a 1 centimeter little antenna, and then it will just pick up the RF that is in this box. So that is an extra output for the frequency counter. So now I'm just going to wire it. Okay, now I need to connect the resistor to the switch. It is going to take this long. Bend a little bit. down. And then it's going to make it like this. Okay. So I already made it as plus minus 12 turns. I think 12, 12 and a half. So that is good. I'm using just VD wire, electricity wire. And I do that because this is isolated, so that is good. So if I just stick it through here, nothing happens. So that's exactly what I'm going to do, because this is for the variable one. And here we connect later the fixed. And we take that from the switch. So, and now you can see what I was trying to do with the switch. Because I will connect it here to the middle wire. So it comes from here. It goes directly to the middle pin, and then you can switch or to the output, so you can put it on the Marconi or another RF device, or I switch it to the bottom, and then it will put all the power in the resistor. And this is a 100 watts one. You can see I fixed it to the bottom with some paste, so it should be able to dissipate. So, and this one I will just solder now like this. So that was some work. I put some time lapse because it's gonna take a little bit. It is ready, and I will zoom in, and as you can see, it looks quite neat. But let me put on the table and let me show you what I did. Okay, here it is. I will zoom in a little bit. Okay, here you can see everything, I think. You see now both schematics at the same time. So first we have the straight through. Goes through the switch, goes out. So input, output. If we don't want the output, we switch the switch, this one, and it will go to the dummy load here on the bottom, and it just dissipates in the whole box. And then we have the simple top. That was the A20, A20, A20. to the output, and here parallel the 50 ohms, and that is this schematic. Oh, that was this schematic. So just on the through cable, 820, 820, 820, out, and 50 ohms in parallel. So that's what we did here. 820, 820, 820, 50. Then we have the variable one that I put on this side. Again, the in and the out is the same. You can switch it to the output or to the dummy load in the back there. And the schematic here, this is the in out. This is the 12 turns is here. You put it on two of the pins with parallel 22 ohms. Well, I have here the 10 and 10 ohms in parallel on the same pin. You put the 50 ohms to the output, and that is what I did here. So that is both, and I put as an extra an output for the frequency counter, and that is just the BNC, and it has just this little antenna, and it will just pick up signal, I'm sure. So then you can really do everything at the same time. So you put your transmitter to the Marconi. There is also the frequency, but you can also pick it up here. And here you have the spectrum analyzer output. Or you use this one either way, or you use two spectrum analyzers at the same time. One for the 40 dB and the other one adjustable like this. And you close it. Yeah, some people maybe notice, hey, wait, they talk about this capacitor here. And I think because you don't see it in all the schematics, but it is just this one there. And I also have that, but I think it's difficult to see. But I just folded the leg, and then you just put the isolation, and here it is. And then we have what we have here. So I did that. So that took a lot more time than expected, but we have a little box, and it is all 3-in-1. So it is a dummy load, it is an RF sampler, and it has a fixed 40 dB and a variable output. And it's all in. I put the markings in. So here we have the RF input. We can go through the variable and then out here. Or it is the fixed output, same RF in, but then it's the fixed 40 out. So this is for the spectrum analyzer or sample output. And so with the switch up to the 50, it is connected to the dummy load, 100 watt dummy load dissipating in the whole box. Or you switch it down and it says here RF output, and then I created a frequency counter output, which is just a very, very little antenna. So that is it. Tomorrow I'm actually gonna test it on a transmitter to see if it actually works, but it's now already a bit late, so I keep it as it is, and well, maybe I see you tomorrow. Thank you for watching, and I hope to see you next time.